Welcome to this video lecture. We are going to discuss about how to find limits of functions of the indeterminate form 1 raised power infinity. So we'll start by this example. Evaluate limit as x approaches 0 of 1 plus x raised power 1 over x. So clearly when you put 0, we have now, we have 1 plus 0 raised power 1 over 0, which is 1 plus 0 is 1, 1 over 0 is infinity. So we have that case for this given example. So we try as much as possible to transform the function we have so that it is either in the form 0 over 0 or infinity over infinity, so that we can apply L'Hospital rule. Now, this is what we are going to do. So we let y to be given by 1 plus x raised power 1 over x. So let's call this one equation 1. And then from this equation 1, we can always rewrite it so that we don't have powers by introducing ln. So we say ln of y equals to 1 over x ln of 1 plus x. We have used the property that ln of a raised power n is the same as n ln of a. All that is clear. Now, also remember, raising, so we raise, call this one equation 2. So our equation 2 can also be written as e raised power ln of y equals to e raised power 1 over x ln of 1 plus x. So raising every so taking exponential of every side of an equation doesn't change the doesn't change the equation. It is still the same equation. And also using the property that e raised power ln of a equals to a, then we can derive this one as y equals to e raised power ln of y, which is the same as e raised power 1 over x ln of 1 plus x. So we are not doing anything else, but we are just trying to use the properties of logarithms and exponential function. So call this one equation 3. So then taking limits on both sides, of equation 3 as x was approaching 0 in the equation. Fact is 0 from the right. That was the equation. The approaching should be 0 from the right. We get so this is equation 3. So we have limit as x approaches 0 from the right of y is limit as x approaches 0 from the right of e raised power ln of y is the limit as x approaches 0 from the right of e raised power 1 over x ln of 1 plus x. Now, recall this property. Recall that if we have the limit as x approaches a of e raised power f of x is the same as e raised power limit as x approaches a of f of x. So we're going to make use of this property. Call this one equation 4. So using equation 4, we have making use of this relationship in equation 4, we have limit as x approaches 0 from the right of y is equals to e raised power limit as x approaches 0 from the right of 1 over x ln of 1 plus x. So this is what we have here. So therefore now let's concentrate on this part here. So limit as x approaches 0 from the right of ln of 1 plus x over x. Remember 1 over x times this one the same as writing this way. Now let's see, by direct substitution we'll have ln of 1 plus 0 over 0. So ln of 1 is 0, ln of 0 over 0. So this is a case of 0 over 0. And then when we get the case of 0 over 0, then we know that L'Hopital rule can apply. So applying L'Hopital rule, we get limit. So call this one question 5. Limit as x approaches 0 from the right of ln of 1 plus x over x is the same as limit as x approaches 0 from the right. When you differentiate this one, you get 1 over 1 plus x. When you differentiate x, you get 1. So this is just like limit as x approaches 0 from the right of 1 over 1 plus x. Now here you use just direct substitution. This will be given by 1 over 1 plus 0, which is 1 over 1, and the answer is 1. So from equation 5, so therefore equation 5 becomes limit as x approaches 0 from the right of y equals to e raised power. Now the limit of this part is 1. So therefore limit as x approaches 0 of 1 plus x raised power 1 over x is nothing but e raised power 1. So just exponential function. So that is what we get. Last example on application of the same. So evaluate B, limit as x approaches infinity of x raised power 1 over x. Now this is the case of infinity, the form infinity raised power 0. So here clearly, so let y to be x raised power 1 over x, and then using ln, we have ln of y equals to 1 over x ln of x, and therefore you raise every side, you apply exponential on every side of this equation, and this, remember, you get the same as y. Call this one equation 1, and therefore now you apply limit as x approaches infinity on both sides of equation 1. So applying limits, we'll have limit as x approaches infinity of y equals to limit as x approaches infinity e raised power ln of y, which is limit as x approaches infinity e raised power 1 over x ln of x. And then you remember that this can be written as limit So we have limit as x approaches infinity of y will be given by, this can be written as e raised power limit as x approaches infinity of 1 over x ln of x. So call this one equation 2. Now we concentrate on this power here, getting the limit. So limit as x approaches infinity of 1 over x ln of x. So this is just limit as x approaches infinity of ln of x over x. So when you put ln of infinity over infinity is infinity over infinity. So therefore, this is the case of infinity over infinity. So which means that the L'Hospital rule can be applied. So this will be limit. Differentiating this one, we get 1 over x. Differentiating this one, we get 1. So this is the same as limit as x approaches infinity of 1 over x. And as x approaches infinity of 1 over x, we just get 0. So therefore, equation 2 becomes limit as x approaches infinity of y, which is the same as limit as x approaches infinity of x raised power 1 over x, because that is what was defining y, is the same as e raised power. That limit is 0. Now e raised power 0 is 1. So therefore, the given limit, the value is 1. So that is how I work it out. Thank you.